Hello everyone, welcome back. So let's start doing some examples of calculating our moment of inertia. What we have here is a concrete block and it's got 3 holes drilled through the center of it. I want to figure out the moment of inertia of this. Now the first thing you should realize is that with moment of inertia, just like with our centroids, when we calculate it, we can say, well, this is a positive, the rectangle right here is a positive moment of inertia, and these 3 circles have a negative moment of inertia. Just like when we were doing our centroid, they had negative areas. This time they have negative moment of inertia. So we can take one complex shape and we can turn it into a series of very, very simple shapes. Now, you don't have to do really any calculations, at least for this problem, beyond just looking up the equation in your textbook. If you look, you can find the moment of inertia formulas in table 3. And so I'll look in there, and for a rectangle, so it'll be moment of inertia for a rectangle, that's going to be equal to the base times the height cubed over 12. And that's going to be equal to, well, its base is going to be 36 inches. The height is going to be 12 inches. That's cubed over 12. And if I plug that into my calculator, that would be 5,184 inches to the 4th. Okay, now, questions here. Why was this the base and this the height? You're like, okay, well, it's because it's this. That's obviously the height because that's the one that's going up and down, and this is the one that's going left and right. That's not it. It's because we went around this axis right here, the central axis. If I had done it instead around this central axis, it would be completely reversed. If you're worried you're going to mess that up, then just whatever axis you rotate around, make sure it's horizontal. So if I had done it around the other axis, I should flip it on its side. And then the height is, just the up and down direction. And the base is the side to side direction. Okay? So don't forget that. It's all based on the axis you're rotating around. So the height is always perpendicular to the axis, and the base is always parallel to the axis. Okay, now I've gotten that for the rectangle. Now I need to get it for the circle. So moment of inertia around that x-axis is going to be, for a circle, it'll be pi times the diameter to the 4th all over 64. And those are 4-inch rectangles. Sorry, 4-inch circles. So it'll be pi times the diameter to the 4th all over 64. And then that would be equal to 12.57 inches to the 4th. 12.57 inches to the 4th. So like I said, this will have a negative moment of inertia because it is a hole instead of being a solid object. And so my final moment of inertia would be, well, I'm going to have the total moment of inertia will be equal to moment of inertia for the rectangle minus 3 of the moment of inertias of the circles. It's going to be equal to 5,184 minus 3 times 12.57. That'll be inches to the 4th for both of those. That comes out to be equal to 5,146 inches to the 4th. Okay, and we're done. Phantasmagorical. So with that, I hope this helps you see how you can solve these problems. Remember, table 3 is your best friend for these. And also remember that the base is parallel to the axis you're rotating around, and the height is perpendicular to it. Okay, thank you for listening, and I'll see you all next time. Bye-bye.